Hello and welcome to Partially Redacted. I'm your host, Sean Faulkner, and today I'm joined by Ben Burkert, co-founder and CTO of Anchor, and we'll be discussing certificate management and internal TLS. Ben, welcome to the show.
Hey, Sean. Thanks for having me.
Yeah, thanks so much for being here. Well, let's kick things off with an introduction. Who are you? What do you do?
Sure. My name's Ben. I'm CTO at Anchor. I'm a software engineer. I've been a software engineer for almost 20 years now. Mostly working on kind of like back-end stack technology kind of stuff. Been a senior engineer, staff engineer at a couple places. Always kind of gravitated towards networking and encryption and kind of like low-level parts of the stack.
Mm-hmm. All the fun stuff. What were you doing before you went and started a company?
Before this, I was at Heroku, working on their runtime team, dealing a lot with like container orchestration, also a lot of networking, and one of their routers, dealing a lot with like just HTTP2 and TLS and kind of all the ins and outs of the request response lifecycle with HTTP.
Oh, cool. Yeah. I mean, Heroku, they were such a pioneer in really the platform as a service game. And I still remember that, like, and I'm sure I'm not alone in this, like that first magical moment of doing like a Git push and it like showing up in a web.
Totally.
For people who now are used to things like Vercel or even AWS Amplify, and there's like so many of these different platforms, like the world was a very different place 10 years ago when it came to web application development. It was a lot more complicated to get something like up and running and scalable.
That absolutely. It really was one of those like early magic moments I had in my career. And trying to host applications before Heroku was just a totally different game. They really changed how it all works. It's the impact that Heroku has had on the DevOps scene and the application hosting scene really can't be underwritten.
Yeah, absolutely. Yeah, I mean, it really was like a paradigm shift. You talk about like category creation and stuff like that. Like that was, they created a category for essentially this whole notion of a platform as a service, which now there's been, I think like great companies that have built on that vision, but they were really the visionaries and pioneers of that.
Absolutely. Yeah. I think, technologies like Docker, Kubernetes, a lot of the stuff that people use for their core businesses, really, a lot of it kind of was inspired, or some of it even directly came out of Heroku's early work.
Absolutely. Great. Well, I am excited to get into this topic. I think, a lot of ways like certificate management, TLS, like as consumers on the internet, we've kind of take it for granted. You kind of just, you now see a little like secure icon when you interact with the website or something like that, but it wasn't always that way. And it wasn't that actually that long ago that it wasn't that way too.
Absolutely.
And there's been a lot of technology behind the scenes that goes into making that whole thing possible and making like a secure internet and a secure network. So just starting, really at the basics, like what is a certificate? What is it used for? How does that whole thing work?
Sure. Yeah. A certificate, the way I think about it is, it's a document that contains some data or some metadata. It says maybe this is a domain name that I own, and it's valid from this date to this other date. So that's one part. That's kind of the information part of our certificate. And then the second part is where the cryptography comes in, and that is a public key signature that signs that data and is verifiable to make sure that that data is correct and can be proven to be correct.
Mm-hmm. So what is that process like? What is the process one of obtaining a certificate, and then how do I actually sort of prove or verify identity through the certificate process?
Yeah. So it turns out a certificate on its own isn't really that valuable. It's a whole ecosystem is required for certificates to be valuable. This signature that I mentioned, it uses what's called a chain of trust in order to verify it. So a certificate is signed by a different party than the holder of the certificate. For example, on my domain, I have a personal certificate for benburkert.com that was issued by Let's Encrypt. And so what that means is that I created a certificate request with the kind of metadata that I wanted to be put into my certificate. and then I sent it off to Let's Encrypt, and then they created the signature of that certificate data. So what I have is some information that describes me, and then a signature from a trusted third party that's verifiable. And that's really important because getting back to this chain of trust, the way that your browser is able to verify a certificate is by walking a certificate chain back to a trusted certificate that it already knows about. To put it a little bit more concretely, when you connect to a website, you establish a TLS connection, and one of the first things that happens is the server sends over its leaf certificates. My browser then takes those leaf certificates, looks at the signature, and matches that to what's typically an intermediate certificate. In this case, that's typically issued by the same CA that's issuing my certificate. So they'll verify that intermediate certificate, and that intermediate certificate will then be verified by a root certificate. And that root certificate is important because my browser has been bundled with a set of CA certificates that my browser trusts. So that certificate is already present in my browser. So I'm able to, or my browser client is able to walk back from the server certificate back to a known trusted CA certificate. And so it has this magic effect of any two kind of clients or servers on the internet, they can establish a secure connection without a trusted centralized party being in kind of the middle of that handshake. It's really pretty magical when you think about it.
Yeah, absolutely. I mean, that sort of chain of command or trusted chain makes all this stuff possible. When it comes to that first part of that process where you're essentially defining this metadata for the certificate, and then you're going to a trusted party which is going to sign a certificate, how do you go about proving who you are? Like, because you basically have to say, like, I own this domain, and then you need to prove that you own that domain.
Right. Yeah, that's a big problem. And actually, this problem changed a lot in around 2015. So I'll start by kind of describing how it worked in the old days. Previously, you would go to a CA company. And this is a company that had done the work to get their CA certificates, the root certificates, into the browsers. So you go to them, you'd kind of like sign up for their website, you'd put in a credit card. They do some sort of manual email verification that you own the domain that you claim to own. And then they charge you $100 for the privilege of basically just creating one of these signatures that really cost them nothing. So the effect was that to get a SSL certificate, it cost you at least $100, and you had to do it like every year. And it caused this kind of prohibitively, it made encryption on the public web prohibitively expensive. So to address that, some the fine folks at like EFF and some other kind of forward-looking organizations decided let's give away certificates for free, and so that's kind of how the CA called Let's Encrypt came about. So they had this mission of increasing encryption on the public web, and they knew to do that they couldn't charge for certificates, and if they can't charge for certificates, they're going to have to automate the entire process of giving away certificates. So from the beginning, they started designing what's ended up being called the Acme protocol. Acme protocol is RFC standard now, and it describes an API for interacting with a CA so that you can prove to that CA without any human intervention that you own the domain that you say that you own, so that CA can then securely issue a certificate for you after proving that you have indeed owned that domain. So that's kind of where we're at now. Typically, to get a certificate that's trusted on the public web, you'll use an Acme client. There's one called Certbot that's a great one. It's written by the Let's Encrypt folks themselves. And it can do what's called either a domain verification. I believe there's a TLS verification. I think it might be called something different. There's a couple ways you can prove ownership of a domain. HTTP is another one. So you have a couple ways of kind of proving to one of these CAs that you own a domain, but now the entire process is totally automatable. It's like totally streamlined. It's really like the creation of the Acme protocol was really a big step forward in terms of like how people get certificates.
Yeah. So is that like, I can add essentially like a DNS entry to my domain configuration, or I can upload like a meta file that has some sort of ID in it that proves that I have server access to do those types of things.
Exactly. It's like a challenge response kind of process. Exactly.
Okay. And then when it comes to essentially like internal and external TLS, like how are certificates managed in that world where we might have internal services kind of talking to each other versus an external client that's connecting into my service? Like, are those set up
Sure.
differently and lead to essentially a different process for achieving certificates?
So fundamentally, it's the same technology. A TLS connection looks the same, whether it's a connection on the public web, like when I connect to Google or any other website on the public web. That connection looks exactly the same as your web application talking to a backend server or that server talking to a database over a TLS connection. The difference really comes down to this idea of web PKI. Um, and so there's this whole ecosystem that a lot of people don't even really interact with, or there's not a ton of awareness around. And it's this ecosystem that's in charge of kind of regulating these public web CAs and bundling up their CA certificates and then adding them to browsers and operating systems and your phone and kind of all of your devices that connect to any device that connects to the internet effectively needs a CA bundle. And so the big difference between kind of internal TLS deployments and public web TLS is that there's no organization out there bundling up those CA certificates for internal organizations. So they're really left to do all of that work on their own.
Okay. And then how does like the management of the certificates, like how are like um organizations essentially managing those for different dev environments? Like, there's local dev, there could be staging and dev environments, and then there's production environments. Like, how in each of those presumably are using, well, you're not using the prod certificate on your local machine, like you need some different setup, right?
Yeah, kind of a good best practice is to use different CAs for each of your environments, because you can use CAs in order to isolate your different environments. So you wouldn't want your staging servers to be able to talk to your production servers. You can use internal TLS and an internal CA to kind of bifurcate those two environments. So even if they like happen to sit inside the same VPC, you can still kind of keep those two things separate. Typically, companies will kind of ignore internal TLS until they really have to, either through compliance or legal reasons. Often, the pain of setting up TLS internally kind of outweighs the benefit. I think that's becoming less and less true, especially as we're moving into more of like a zero trust world. But that's kind of a different point. But what people typically do is either kind of ignore TLS in terms of their internal organization. Sometimes they'll deploy public TLS certificates internally. Now that Acme exists and it's so easy to automate, it actually makes sense for some people to just provision a public certificate for their internal service. That does have some drawbacks. You do have to expose bits of your internal service to the internet. There's also something called certificate transparency now. It's a service run by the CAs with the goal of preventing certificate misissuance.
Mm-hmm.
So you wouldn't want someone to randomly just start issuing Google.com certificates. So all of these CAs have to basically publish certificates that they provision to a public ledger. And that ledger is audited by everybody else. But that means that if you issue certificates for your internal infrastructure, information about those certificates is discoverable on the web. For example, whenever you provision a certificate, within a few seconds now, you'll start getting like web requests, kind of probing requests, because attackers are watching those certificate transparency logs to kind of find endpoints to attack. So kind of to go back to, I think the question started off with, how are people deploying internal TLS into different environments? Typically, they wait until they have experts who have deployed this stuff before. Internal TLS and just X509 and TLS, it's kind of one of those areas where it's super critical, but there's not a ton of understanding about it out there.
Mhm.
And so, in order to do this stuff properly, you really have to like hire experts who have done it before, who understand it, because it's so easy to shoot yourself in the foot with this kind of technology. So, typically an organization will wait till they're a little bit bigger, a little more mature to bring on those folks and kind of build out those security teams.
Yeah, I think it feels like for a lot of companies, like especially in the early days, it's like one of those things where it's a problem that you deal with, and once you've like put something in place, you kind of move on and you've forgotten about it. So it's hard to sort of build up like expertise unless you've really like specialized in this domain, because it's something that you kind of set and forget one time, and then until it like expires and you have to like reset it and stuff like that. And I think that's another interesting thing is like and it's been a little while since I've dealt with my own like uh TLS certificate management and stuff like that, but I can remember the idea of an expiring certificate really striking the fear of God into anybody, because like you're really like
Oh yeah,
you're going up against like some timeline where the certificate's going to expire, you need to rotate it, put in a new certificate, and it's been a year or two since the last time you did that, and you might not remember the way that everything went
right,
down, and you really risk the possibility of taking down your service during that
absolutely.
process.
Yeah, it's both critical and tedious, and that's
Mhm.
like a dangerous combination when you put those two things together.
Has things gotten better on that front?
I would say Acme has made it better, certainly, um, especially on the public web. Internal TLS, Acme hasn't done much to address kind of the pain and the toil of running internal CAs. Um, there's products out there that provide an Acme endpoint for an internal CA, but won't help you with kind of like the running and the managing and the making sure that every year you're renewing this before it expires, before you're woken up in the middle of the night and everything's on fire, and these types of problems. So it's getting better, especially on the public web, but I would say internal TLS is still kind of lagging behind in terms of the tediousness of managing certificates.
Mhm. And what about like local development? Are people doing self-signed certificates? Like, what is the sort of typical setup that people are following there?
Yeah, it's interesting. I would say the majority of folks, and this was certainly true for most of my career, are just turning off TLS in development, just figuring it's too much of a pain to set up locally. There are tools now that are great at setting up local CAs. Stuff like MakeCert, MKCert is a great one. Those tools typically focus on kind of the individual developer, so they'll help you set up your own development environment. They And then if you're working on a team, everyone kind of has to do it all themselves. So this is an area we've been trying to address. We've created a tool called LCL Host, which follows the same kind of strategy of setting up HTTPS in your development environment. To kind of harken back to my Heroku days, there was like an important concept at Heroku called 12 factor. It was like 12 factors to make your app like perform well, scale well, all this sort of stuff. One of the factors was dev prod parity. The idea is your development environment should match your production environment as much as possible. And what that does is you reduce bugs because you can catch them in development before they ever go out to production. And I think this is I think this idea has really caught on for developers. But when it comes to kind of local encryption, there still is this dev prod parity gap. And so we built LCL Host to kind of address that dev prod parity gap. The idea is that you can use the same encryption that your application uses in production, but you get it in your development environment. And it works across your entire team so that you can set up an app, it can get encryption going, one developer can do it, and then everybody on the team kind of benefits from that, from the the application being set up for encryption.
Mhm. Yeah, I think there's been what I think is a really positive movement, but like a movement. It's still like early days, but shift to trying to get as much sort of dev to prod parity. Like in the days of like, but it works on my machine.
Yeah.
With there's the whole movement around remote dev environments from companies like Daytona or Code Spaces is another tool
Mm-hmm.
that allows you to do some of that stuff. But it you're right. Like there's still this gap when it comes to like TLS, and like if you turn off TLS locally, I would think that that's going to cause a number of potential problems. Like even if you were using something like gRPC depends on HTTP2, which it's technically not required TLS, but it's assumed that it's there. And
Right.
if you're kind of hacking away not having TLS because you're running it locally, like I got to imagine at some point that's gonna shoot yourself in the foot.
Absolutely. Yeah. You really have to kind of, especially with HTTP2 and gRPC, you kind of have to you have to do extra work to disable TLS to get it working with gRPC. So our kind of philosophy is like, it should be easy to use TLS in any environment. So you don't have to, as a developer, go through the rigmarole of like disabling things in your development environment or purposefully making your development environment not match your production environment.
Yeah, I mean, it seems like whenever you're going into your way to turn off things that are there for security purposes in order to make things like just like work, it's probably not like the best mode of operation. Like it's going to lead to some kind of problem inevitably.
Absolutely. That it'll eventually lead to problems, and those problems typically happen at like midnight or on the weekend, and those are the ones that send you cause you to wake up at midnight.
Mm-hmm. Yeah, absolutely. So you've kind of talked a little bit about it, but tell me more about Anchor. Like how does that work, and how does that kind of fit into helping solve some of these problems?
Sure. We started Anchor a little over 2 years ago. And my co-founder and I had both come from Heroku, and we'd seen kind of how big of an impact Acme had made. Heroku uses Let's Encrypt for a lot of their certificates. But we weren't able to use Let's Encrypt inside of Heroku because we needed to run private CAs there. So Acme exists, and it's great, and it solves this kind of one half of the TLS problem. So that's kind of led us to, let's say, like, hey, let's see if we can take Acme and see how else we can improve internal TLS for companies. So the way we think about it is, for internal TLS, there's really two problems. There's the provisioning problem, which is getting certificates onto servers, and Acme is great for that. And then there's the distribution problem, which is updating all of your various clients to trust the certificates that your servers are presenting. This kind of harkens back to the web PKI browsers, operating systems are doing that for free for you. But for internal TLS, there's just no equivalent of any of that happening. So we started building Anchor with these problems in mind. We wanted to make provisioning really easy through Acme for internal CAs. And we wanted to solve the distribution problem so that people, even if they're using internal TLS, they're not spending all of their time updating magic certificate CA chain files on their file systems, or figuring out how to update a Docker image to make sure that they've got the latest CA version over here. And to do that, we build language and OS packages so that in a Docker run or in your Python project, you can pull in a Python library that installs the CA chain so that it's much more, it brings a problem from kind of being a nebulous operations, whoever's building containers, someone's just going to drop these magic files on the file system. Instead of that problem, it's now just a regular package dependency problem for developers. We've already got great tools for that. So let's lean into those tools that already exist. And so by solving kind of both sides of the distribution and provisioning problem, we make internal TLS much more approachable and practical for developers so they can really self-service, and they don't have to rely on like a security team to go in and set all this stuff up properly for them.
And then I'm going to use essentially that structure where I'm pulling it in kind of like a package. regardless of whether I'm doing that on local dev environment or I'm running this on staging or I'm running on
Right.
this on production.
Right. And you already, language package ecosystems already have ways of kind of activating packages based on which environment you're in. So you can say, in this environment, activate this NPM package, but in this development environment, use the development version of that. So you already get you get this kind of built-in ability to say your staging instances boot up in a way where they can't talk to production instances, and vice versa. You can keep that kind of strong bifurcation in your TLS CA structure. I should say that our the way that we build and manage CAs, we're a fully managed product, so we host all of the CAs ourselves, and we always do what's called a two-tier PKI. So we really match the public web in terms of how they build and deploy CAs. So we always issue leaf certificates to your servers. Those leaf certificates are signed by sub-CA certificates or intermediate certificates. And then those sub-CAs are signed by root or anchor certificates. And we follow this pattern because we build in a templating system into the middle intermediate sub-CA layer so that each application gets its own sub-CAs, which means, and we can, there's ways with X509 to enforce name constraints and different rules to say that this sub-CA only gets names for this service. So we can tie that to the credentials that you use to provision certificates so that for a given set of credentials, you can only get a certificate that's for, let's say, service a.staging.mycompany. So by kind of following the architecture of public CAs, we can really kind of go beyond what you typically see in terms of like sophistication in a internal TLS CA deployment.
Yeah, that's really cool. And how does it work with sort of like the mapping of domains? So these different environments are going to have presumably different domains and maybe the internal services and stuff like that, and maybe their subdomains. So like, how do I end up being able to run those things across these different environments, including locally?
Sure. There is a part of X509. X509 is the standards that say, this is what a certificate is, this is what it looks like. There are parts of the X509 standards called name constraints. So in the actual certificates themselves, you can say, any certificate issued by the CA has to match this name constraint. And that's going to be a suffix of a domain. So staging.mycompany, for example, could be a name constraint. You could even say, you can even kind of like do the inverse and say, I'm going to reject any requests that contain the word production in this sub CA, for example. So this is baked in at the X509 layer, which means that, we're not enforcing this kind of in our SaaS layer. This is happening every single time a client talks to a server. And so what that means is that the servers can know, it can reject certificates if somehow someone gets credentials for a staging instance and they try and provision a production certificate. Even if they're able to do all that, the chain of trust is still going to reject those certificates. So it's really kind of built in at the lowest layers. And this ability to kind of bifurcate or separate different environments, you can do it based on domain names. You can do it based on IP addresses. You can actually get public certificates for IP addresses. If you go to 1.1.1.1, you'll go to Cloudflare's like public DNS endpoint. Those public IP address certificates, not used very much in the public web, but they're actually pretty useful for internal TLS where you might not want to like rely on DNS for some of your critical internal services, for example. So there's a couple different tools you have available at kind of the X509 layer that lets you really dial in how you want to customize and separate your different environments.
And as a user, like is someone adopting this approach and using Anchor, like what is that process look like? Like how do I go from day zero to essentially getting something set up where I can manage these internal TLS certificates?
We rely heavily on the Acme clients that are already out there and exist. A lot of languages have great support for Acme built in already. So if you're running a server in Go or Python or Node or Ruby, like most major languages have really good Acme support already. And so we want to like build off of that really good Acme support. So we use a portion of the Acme spec called EAB tokens, which is not how a lot of the public CAs use Acme. But for us, it allows us to bypass the Acme challenge process. You don't have to publish DNS records in order to get to prove that you own a domain to Anchor. What ends up happening is that when you do the Acme workflow, you're using API tokens that have already been loaded into your environment, and you're kind of like stapling those Acme requests, those tokens to that Acme request, so that by the time we get your requests for certificates, we already know exactly what level of permissions you have. So this has the nice effect of like speeding up the provisioning process. We actually encourage people to move provisioning into the boot process of containers because it can happen that quickly. We also recommend building kind of caching layers so that if you're provisioning a certificate for 2 weeks, you're renewing it every week so that you have some resilience. If our control plane was to go down, it wouldn't cause an outage for your critical services. So we're really leaning heavily on using Acme for automation to provision certificates. And then the other half is the packages that I mentioned, actually having developers integrate their application so that their clients are loading the CA from our packages that we build for you, as opposed to like relying on the file system or manually editing CA files and kind of all of that muck.
Mm-hmm. And in terms of like the companies that you're working with, are they typically migrating from some hacky process that they put in place today to Anchor? Or are they like what does that look like? Or are they starting essentially? They're building net new and they're doing this from day one.
Yeah, building from day one. The setting up these internal TLS deployments, kind of like you said, once you have it up and running, there's not a lot of incentive or motivation to really futz with it. So we're really going after looking for those kind of smaller companies that probably don't have a security hire yet, but they know because of compliance reasons, or maybe they've realized they've got to be in multiple AZs or moving data across VPCs. They really need some extra encryption that their infrastructure doesn't provide them. But they don't want to hire, like a security consultant who charges way too much. And so we're trying to be that kind of first security hire for those folks and really help them scale with them.
Yeah. In terms of like, adopting this as a, younger company that doesn't have that security professional, like how much do I need to know about like how any of this works, or is it, pretty much just self-serve? I just need to understand that this is something I need and I can kind of just, go and, click through some things, read the documentation and get up and running.
Yeah. Our goal is really to make it approachable and usable by developers who have an awareness of TLS. They know that this is the encryption layer, but haven't, gone through the pain and the heartache of like trying to do this stuff yourself. If you ever used OpenSSL from the command line, it's just like trial by fire, trying to get it to spit out a certificate that is correct.
Is there any human on the planet that knows all the potential parameters that you can put into like OpenSSL? It's crazy.
Possibly, I'm not even sure ChatGPT could ever know all of them. Like it's such a crazy like interface. It's true. Yeah.
Yeah. I mean, you can do everything from, I feel like there's enough parameters in there. There's like some secret parameters that probably like power the entire internet. Like it's like so much stuff that's like built into that computer. It's an entire operating system essentially baked into this like little command line tool.
It's wild. And there's flags and parameters that like undo other flags and parameters. I've heard that, CAs have to hold these root CA certificates. Typically, there's all this process around securing root certificates because, like, if these things leak out, then it's massive. It's like, the CA is basically out of business if they leak these certificates. So they have these like manual binders that explain like the exact flags to be using and why they're doing this. It's just like there's so much like manual infrastructure around this terrible interface that's just been there for 30 years at this point. It's a lot.
Awesome. I mean, I think that for anybody who's gone through any of these processes themselves, like if you built this stuff previously at another company, I don't think this is something that you're eager to build again at another company. So if you can kind of like offload that to a service model, like that's fantastic. Because this isn't like the stuff that most companies want to invest like their time and resources into building.
Right. Yeah. This is it's really like boring, tedious works. Making sure that certificates renew at regular intervals, like this is the part of security that I think there's nothing sexy about certificates, but what they do is so important. I've worked on similar stuff in the past. I was working at with the security team at Cloudflare, and they were doing like amazing stuff with TLS. They built this ability to basically remove the private key from TLS handshakes, and you could like host it on a different server. I just remember seeing like all this awesome engineering happening around like TLS. They really understood like what was happening at every layer. And then I also saw like certificates expiring at midnight, and like the same operational issues that people have with CAs were impacting us. And that was kind of my impetus to say like, hey, even if there are some technical challenges to solve with encryption, but even if those get solved, there's just so much operational issues. These tools are terrible. There's so much toil involved with dealing with certificates. There should be a product that just addresses like the toil and the pain of just dealing with certificates, and kind of doesn't even like thinks about encryption as almost like an after effect. So we really haven't done anything innovative in terms of encryption. We really just use what works on the public web, what parts of TLS are great, and then we just try and attack all of that toil and manual operational muck.
Yeah, I mean, I think you've identified like a real pain point that I feel like you have a conversation with any engineer that's done any of this stuff, and they'll tell you war stories from the front. Like it's just like one of those things I think that people have in their back pocket.
Absolutely.
Like 5 stories of horror that they've gone through in their career dealing with this kind of stuff. And it's not the fun stuff, but it's highly specialized work that the cost of doing it wrong is massive.
Right. That's another key point, is that the cost of doing it wrong is massive. And that's really what kind of, I think, has caused the effect of people just kind of ignoring this stuff way past when they really should start thinking about it. And so the effect is that when you do want to add TLS, it's just way more expensive because it's such a bigger jump up or a bigger investment to do it right and to do it everywhere.
Mm-hmm, absolutely. Well, Ben, is there anything else you'd like to share?
I think by the time this comes out, we're working on some new features for LCL Host. LCL Host is the tool I mentioned earlier. It's a great way to set up HTTPS in your local development environment. It's also, I believe, the first tool that allows an entire team to set up TLS together. So you can configure an application for TLS, push it up, and then everybody on your team, all they need to do is install the Anchor toolchain, run one command, and now everybody's using TLS in their development environment. It's really, we dog food it, and it's really helped us like make sure that we're always like sticking with that dev prod parity 100% as much as possible, especially for encryption. So go check it out at lcl.host.
Awesome. Yeah, and we can add that into the show notes. Well, Ben, thanks so much for being there. This was really, really fun. It was good, reminiscing, some, PTSD from some of the early days of my career dealing with all the certificate stuff.
Yeah, I think you're absolutely right. Everybody has a story about this stuff, and there's a lot of PTSD out there. Mm-hmm. Thanks for having me.
Cheers. Bye.
Bye.